Hi guys, this is lesson 7. We're crazy. We're almost done this unit. Hope everything's okay. As usual, please let me know if you have any questions or any problems. This lesson is kind of an extension on the last lesson. It gets quite a bit more complex, and it looks at solving trig functions or trig equations. So finding angles that would solve an equation. So this is really similar in technique as to what we've done already, but it's going to combine a few things. So like, if we look at this first example where it says solve this equation, if you were asked to solve this equation, what that means is you're looking for x values where this equation is equal to 0. And so in order to do that, what do? We have to factor because it is a quadratic. And so what we're going to get into is situations with trig functions where you have a quadratic trig function. And so remember your rules here. You've got an AC value that equals -2, and you've got a b value that equals -1. So what you want are two numbers that multiply to give -2 and add to give -1. And so that's going to be -2 and +1. So what I do is I break up this factoring into those two factors, -2x, I break, -2x, break that up, and +1x. And then I factor the first two terms, a common factor, so that becomes 2x, and that leaves x minus 1. And then there is no common factor, so I just take a 1. And so we're almost done. We have 2x plus 1. We group those, and then x minus 1. So hopefully that's very much review. And so the last thing we have to do is actually solve this. So I say 2x plus 1 must be equal to 0. I rearrange it. And so I get 2x equals -1 or x equals -1/2. So that's one answer. And then the second one, I just simply move the 1 over and I get x equals 1. So that gives me two answers for this. So this is what we're going to be doing only now with trig functions. And so this example here follows that same idea. It says solve this equation for theta, where theta is between 0 and 360 degrees. We have to state that domain. Otherwise, you could have answers repeated that go on and on and on for angles beyond 360 or below 0. So when I look at this question, the first thing is it's a quadratic. Sometimes the easiest way to approach these is to replace sine or cosine with a variable. So I'm going to say let x represent sine of theta. So I'm going to replace sine of theta with x. So this is going to be 2x squared rather than 2 sine squared. And then minus 7x plus 3. So again, we want to factor this. Excuse me. So two numbers that multiply to give +6 and add to give -7. So it's going to be -6 and -1. So I got -6x minus x plus 1. Let me go through this process. So I end up with 2x minus 1 and x minus 3. So I still need to solve it. And I'm going to solve it in the form where I have it as x, because I think that's easiest. So I have 2x minus 1 equals 0. So 2x equals 1, or x equals +1/2. And then this one is x equals 3, obviously. So now I can go back and say, oh, what was x? X was sine of theta. So I'm going to do the right one here first. Sine of theta equals 3. And so this one also is going to be sine of theta equals 1/2. If I want to solve for this, and it's not an exact value that I recognize from my trig or my special triangles, what you want to do is you just say, okay, theta is going to be the inverse sine of this. And I've chose this one because I know it's not going to work. I know that this is going to be an error. And I want you to think to yourselves, why is this an error? What of this ratio makes it impossible? And the reason is because you can't have a ratio for sine greater than 1. So this cannot be greater than 1. Because the opposite over the hypotenuse, you can never have the opposite be greater than the hypotenuse. This one, on the other hand, definitely works. And so this one is from one of our special triangles. And so remember this one, you got 30 degrees, 90, and 60. opposite of the 30, which sine uses opposite over hypotenuse, opposite of 30 is 1 and the hypotenuse is 2. So in this case, my related acute angle that I want, or alpha, is 30 degrees. And if you need to, you can draw out the little quadrant system and figure out where else you're going to have an angle that works for sine being 1/2. And you can use your cast rule, knowing that this is a positive value here, plus 1/2. That means it's going to be in the all category and the sine, because that's where sine is positive. So I know I'm going to have these quarters of my bow tie and the related acute angles inside here. So our related acute angle is one of our answers for theta. The second theta is going to come from 180 minus that related acute angle, so 150. And so therefore theta equals 30 and 150. And we're done. That's it. And so again, a few things, but not super complex, but a few things going on there. So if you want, why don't you try this? Actually, this one's got a little bit of a trick, but once I get show you what to do off the beginning, I think you'll be able to get it. So this one says solve, and we get 6 cos squared, but then we have a minus sign. So I've actually got two different things. So it's not a pure quadratic at the moment. And then minus 5. And again, we're between 0 and 360. And round your answer to the nearest tenth of a degree. So in this one, the best thing to do is we need to get it in terms of sine or cos. And so what we can do is use trig identities to rewrite in terms of sine or cos. So that we'll have it as the same trig function. So if you notice, cos squared theta, which we have, is the same as 1 minus sine squared theta. And if I replace that, then I'll have everything in terms of sine. So what I'm going to do is that. I've got 6 cos squared theta minus sine theta minus 5 equals 0. And I'm going to replace this with the Pythagorean identity. So once I do that, if you want to, you can pause the video and see if you can complete this question. So pause it, see if you can come up with solutions to this one. So the first thing I need to do here, and you can always pause at any point, but I got 6 minus 6 sine squared theta minus sine theta minus 5. So I got minus 6 sine squared theta. I'll collect these like terms. So I've got minus sine theta, and then I've got 6 minus 5. So that's just going to be 1. So plus 1. And I don't really like this negative, so I'm going to divide everything by a negative, or just change the signs like this. Then the next step, it's easiest, I think, if you say, like we did before, let x represent sine theta. So I end up with 6x squared plus x minus 1 equals 0. And it's amazing how all these, so often in math, you just have these factoring questions pop up. So this time I need two numbers to multiply, give negative 6, and add to give positive 1. So I've got 6x squared plus 3x minus 2x minus 1. So I can take a common factor of 3x, so that leaves 2x plus 1. And then a minus 1, so that leaves 2x plus 1 as well. And so this, I'm going to do it in one step, so that's 1/3, and this one's going to be x equals negative 1/2, like that. So we've got two things that are actually going to be valid. So I'm going to rewrite this over here. Actually, I think, did I make space? Yes, I did. So I don't need to. So I'm going to deal with this one first. So remember, we have to replace this back, so it's sine theta equals 1/3. And this one, if you think, is there a special angle that works with this? No. So what I need to do is I need to do the inverse sine of 1/3. And I'm using alpha. You could just, because this is positive, the related acute angle is one of your answers, but otherwise you can do it like this. So this is approximately 19.5 degrees. And this is similar to what we had before. I've got sine is positive, so I know it's going to be in the top quadrants. So I know I'm going to be up here, but I'll just do this so you have it. You don't always have to write this in. So knowing this is positive, I'm up here and here. I'll go quickly. So here's my alpha. So therefore, I've got, in this case at least, theta equals 19.5. That's the first theta, and theta 2 is 180 minus 19.5. So this is going to be, what's that, 160.5. So that gives me that one. And then this one, I'll do it over here. So again, I need to replace, this is sine theta equals -1/2. Therefore, alpha is going to be, again, this is the related acute angle, it's 30. But when we draw this, using the cast rule, it is negative. So where are we going to be for sine being negative? Down here. So my related acute angle is not one of my answers in this question. I'll take my time. I was ashamed of the last drawing. So this one, we get alpha in here. And so that we have, let's call that theta 3 since we've already had one. So theta 3 equals 210, or 30 plus 180. And then theta 4 equals 360 minus 30, which is 330. So therefore, overall, theta is 19.5, 160.5, 210, and 330. So we get 4 answers. It's a lot going on. So some good questions here to try out. I've reduced the numbers, so hopefully it's not too much. But as always, please